Good afternoon, everyone. I hope everyone is having a good summit so far. Yay? Nice. All right. Hey, look, I'm going to start with an assumption that you're here because at some stage you came across a use case where you wondered that, look, you know what? I would love to solve this problem using some of the AWS services if only AWS was available right inside my data center or at my customer site. Or you're one of those who are already running workloads at the edge and are here because you want to learn more about some of the design considerations and best practices for running applications at the edge, especially the mission critical workloads at the edge. Look, my name is Ratan Kumar. I'm one of the principal solutions architects here at AWS. And I would say that I've been super lucky to actually get to work with a number of our customers doing some really interesting things at the edge. In fact, we will get to hear from one of them today in this session. All right, so what can you expect to hear from us in this session? Look, we'll start with why and how AWS is creating a cloud platform for every use case. Then we'll dive a little bit into what are some of the challenges of running workloads at the edge? And what is AWS doing to help enable customers to address some of those challenges? Then we'll hear from Vector, that how they are reimagining the electricity distribution network using AWS Edge services. And finally, we'll wrap it up talking about some of the design considerations and best practices for deploying workloads at the edge. So let's get started. Look, at AWS, we are constantly pushing the boundaries to make cloud capabilities available to almost everywhere. In fact, to some of the most unusual places. Just to give you an example, we recently had the astronauts of Axiom space mission took AWS Snowcone device to International Space Station. Why? Because they needed a platform to run machine learning inference in the International Space Station, all aimed at improving the experience of future crew members. What was quite cool about that setup is the ground staff of the mission could actually run or train the model in one of the nearest AWS region and then remotely deploy on the Snowcone device inside the International Space Station. Pretty cool, right? Anyway, space is the final frontier and something that continues to intrigue all of us. But coming back to Earth, right here in ANZ, we have a number of our customers doing some really, really cool things. I mean, just to give you some examples, we have customers like Spark using AWS Edge services, 5G, and machine learning to build solutions that is going to meaningfully improve the health and safety at industrial sites. We have customers like Halter using AWS IoT to enable farmers build most productive and sustainable farms. Then we have customers like Vector, who we're going to hear from today, using AWS Edge services as they power the electricity distribution network of the future. So what I want to say really is that we remain relentlessly focused on ensuring that world's most comprehensive cloud capabilities are available everywhere and for every use case, from the cloud all the way to the edge. Now, talking about edge workloads, look, we have been running edge workloads in our Amazon.com business for many, many years with sortation machines and robots. So we are very familiar with some of the unique challenges of running workloads at the edge. I mean, it's hard, look, because you got to think about how you're going to ensure reliable connectivity between workloads running at the edge and control plane running somewhere else. You need to then think about how you're going to ensure store, process, and back up your data. You need to think about compliance and security at the edge. On top of that, developers today have to often deal with different toolings and platforms depending on whether you're deploying the workload in the cloud, on premises, or at the edge, which really adds to the whole complexity. Additionally, edge deployments are typically influenced by what we like to call at AWS 3 laws of distributed computing. First, law of physics, which is all about the speed and of the transferring this data over the network. And then you have the law of economics, which is about the cost of this ever increasing volume of data. And then finally, law of the land, which really governs where you can store and process your data. So what is AWS doing to help customers address some of these challenges? So before we go far, I just wanted to cover a little bit of a history here. So way back in 2006, when we started, our focus was to build lots of regions, each with multiple availability zones. And today we have 31 regions. We're constantly adding more. We recently had Melbourne region come alive. Next year we are expecting Auckland to come alive. But then our customers came and told us that, look, this is great, but there are certain workloads that we would love to run in AWS, but we can't. And they had some really valid and strong arguments for it. Why? Because these workloads needed to work in a very strict latency budget, or they needed to remain on-prem because they can't send data across the country. So there were regulatory and compliance reasons. So that's when we started to think that what can we do to make the cloud capabilities that we have built and extend it and make it available on premises as well as the edge, and while ensuring that they have got the same consistent experience. So today, depending on the use case that you have a number of different choices. So let's say you have a low latency use case where you're looking for an AWS infrastructure in a large metro city. You've got local zones. There are 32 of them. We're adding more. We recently had a local zone come alive in Perth. There are 2 more local zones that we are bringing in this part of the world, in Auckland and Brisbane. If you have an ultra low latency use case, like AR/VR application, connected vehicles, you can use AWS Wavelength, where we place AWS services right inside a telco network. Again, the whole focus is that how do we reduce the number of hops that a packet has to travel to achieve that low latency, ultra low latency. If you have a use case where you're looking for AWS services right inside your own data center, you can use AWS Outposts. If you have a use case where you need to control smart things and its devices in a remote location, you can use AWS IoT family of products. If you have a use case where you're looking for AWS literally inside a suitcase, you can use AWS Snow family of products. So there are a number of choices that we've got available to our customers depending on your use case. But what's the best part? The best part is that across all the choices, you have got same consistent AWS experience, same APIs, same toolset, which is great. Now the developers have less complexity to deal with depending on where they're deploying the workload. Additionally, we know that a number of our customers are using containers and Kubernetes as they modernize their applications. You can use Amazon EKS or Amazon EKS anywhere to deploy your Kubernetes workloads in the cloud, on premises, as well as the edge. All right, so now let's talk about an edge workload with a real customer use case. As I said, we have been running edge workloads for many years, in our Amazon.com business. And look, these systems need to run reliably. Resilience is very important because any outage means delivery delays, broken prime SLA, and hundreds and thousands of grumpy customers calling Amazon.com call center. We definitely do not want that, right? So these systems need to run reliably. Resilience is important. But working with Vector team, what we quickly realized that resilience expectations are orders of magnitude higher when you are thinking about running an application that is going to control the electricity distribution in the largest city in New Zealand, a city which is home to 30% of New Zealand population, a city which drives economic activities, contributing about 30% to New Zealand's GDP. It's a pretty big deal, right? And to talk more about it, I would like to invite on stage John Martin, Principal Solutions Architect from Vector New Zealand, and a visionary technology leader who spearheaded this project right from the start. Welcome, John.
Cheers, man. Hi, everybody. I'm John. I work for Vector Energy Group, and I work for a specific part of the business called the Vector Electricity Group, which we do distribution, as Ratan just said. And so what is distribution, really? So very specifically, we handle these yellow lines, basically. We take electricity from the transmission substations and we ship it up and down the city to people's end houses. And as you can imagine, that's a very distributed nature. We have a lot of zone substations that sit around the city. We have a lot of pipes. We have a lot of wires. We dig a lot of tunnels. And this means that we essentially have an edge problem that we need to solve. Now, what's happening in our industry is as things like electric vehicles and solar PV become more and more common, the profile of the customer is changing pretty dramatically. So we have a very large consumption change in terms of what we're looking at. And so we're getting one of those typical kind of hockey stick graphs in terms of what we're seeing. So we need to be able to scale. Customer demands are changing. We are expecting more at the house. We need to build more, produce more, go faster. Now that's interesting in this industry, which has been a very conservative industry for a very long time. Typically OT industries or operational technology industries like ours are built in a very closed network kind of a view. We have, in our network of zone substations, we have a closed network of fiber that goes back to our data centers. It doesn't connect to the internet. There's no shared infrastructure anywhere. And the whole thing is based on a very centralized view of the world. Now, the people that control this network are our electricity operations center up in the top left corner there. And those people are a combination of electricity controllers, so you can imagine the typical people, lots of screens, lots of keyboards, switches, this goes here, that goes there. When someone hits a pole with a car, they have to reroute power to get the customers back online as fast as is humanly possible. Those are our controllers. And we also have teams like our OT engineers who are part communications engineer, part network engineer, part system admin, and part electrical engineer. They're very T-shaped kind of people. And these are people with enormous amounts of skill, but also enormous amounts of experience. And what's happened is, if we want to hit that growth curve, and if we want to scale our output, we can't rely on having the same types of skill sets as we used to have anymore, because you can't just buy these people, you can't just produce them like this. And so we have a merging of different skill sets, we have an updating of people coming into the environment. Now, Vector itself has a fairly mature corporate IT department with a lot of skills in AWS, a fairly robust program there. And what we wanted to do was bring some of that in and change our core system that does this control. And so in that control center up there, you're typically running a SCADA system. And a SCADA system is a pretty basic system that has devices. Those devices speak Modbus or DMP3 or something like this. They give values or statuses, and they send it back to a system. If you teach that system about distribution management problems, you let it be drawn as a schematic, you have what's called a distribution management system, which is a DMS. And if you have a fancy system with a bunch of stuff around the edges, like outage management, switch order management, those type of things, then you have an advanced distribution management system, or an ADMS, which is what I'll use for short for the rest of the presentation. So we decided to install an ADMS. This was going to let us get data from in our OT, ship it out. It was going to let us make better decisions, quicker decisions, less outages for our customer, more scale, faster delivery. But to do that, we needed our infrastructure. And we couldn't just rely on the same skill sets that we've always had. We had to bring in new things. So let's look a little bit at what we needed for our requirements around infrastructure for the ADMS. So obviously, it's a power system. It needs to be reliable, secure, and have high performance. And that's a given for any kind of OT situation. Everything in OT is doubled up: reliability, reliability, reliability. We have redundancy everywhere. We needed operational consistency between environments. We needed a consistent set of APIs and services between our sets of environments so that our teams could respond quickly to any issue that we had, and we could deliver the right service to our business. And once we have those consistent services, then we can use common tools for deployment, for automation, for our security controls. These OT systems aren't typically ones that have seen this level of automation for a very long time, and we needed to bring that in. And ultimately, that lets us do the same pace of innovation in OT as we have in our cloud. So we decided to choose an outpost. So What's an outpost? It's a server rack. It's 42-unit rack. There's one of them out there. But basically, it's got 2 cables coming out that go local, 2 that go out that go to your service link that I'll talk about in a minute, and some power cables, depending on whether you go 3-phase or single phase. But it's very important for us because in an OT environment, you're not going to have the same appreciation of the cloud, where I'm renting somebody else's computer, as a corporate system. People need something physically on site. They need reliability. They need to know it's going to be there when they want to use it. They need to know it's going to work all the time. And so this particular outpost gave us that reliability. And once we were done with all our testing, we were very happy with how it performed. So here's our architecture picture. In the pink, you have Vector's data centers. We've got 2 of them because redundancy. And so what you do is you log into Amazon. Everybody gets on a Chime call. And you have a very nervous meeting where you order it like any other service in Amazon. And you spend quite a bit. And you push the button. And then a little while later, the outposts arrive. And they arrive there. And then what do? We connect our service link. So this is basically the management traffic that goes back and forth to region. So that allows me to log into the console. It allows the outpost to then populate and build itself. And it allows me to start spinning up EC2s, building things. Next thing I do is I build a VPC. I stretch my VPC, separate across 2 outposts for reasons that will become obvious in a minute. And I separate it between region and on local. Then I build a subnet, get my IP space working, and then I start installing my nodes and my database servers and things like that. And then ultimately, I have my traffic on my local gateway. And this is very important for us and was one of the key reasons why we chose Outposts. Because this is where all the application traffic goes. So if I want one of my instances in DC1 to speak to DC2, all of that traffic, all of that application traffic goes through my firewalls. It doesn't go back up to region. It's not handled that way. We're not dealing with it like it's local IPs. It all goes through that same infrastructure. And so functionally for us, this is no different than if we were buying blades and running it on VMware. So.
Thanks, John. Look, it has been great partnering with Vector team on this really interesting project. In fact, it's another example of how at AWS we like to collaborate with our customers and partners as we solve some of the most pressing industry challenges. So based upon some of what John has shared with us, in next few slides, I and John would like to share with you some of our learnings, when it comes to running workloads at the edge, especially when you're deploying it on Outposts inside your on-premises environment. But before we do that, I just want to highlight one very, very important thing, and that is a little bit on the roles and responsibility. So like resilience, security in cloud, similar to that, when it comes to resilience, it's a shared responsibility between AWS and you as a customer. So what do I mean by that? I mean, AWS will, of course, take care of resilience of our global infrastructure, ensuring that our global network backbone is resilient, and continuing to build features and services, as well as continue to provide you a set of prescriptive guidance to help you enable resilient applications. But then you as a customer are responsible for ensuring that you're using those features and guidance to make sure that you're designing and deploying your applications in a way that meets the availability needs of your business. So with that out of the way, let's talk about how do we approach building resilient applications, So there are a few different approaches, right? And the approach that we believe works really well is when you think about it in terms of all the different failure scenarios. When you're running a large distributed applications, whether you like it or not, things are going to fail at some stage. You can have a network issue affecting your workload. You can have an issue within your data center or an event within one of our availability zone affecting your workload. There could be computer storage node problems. There could be issues injected because of bad code or configuration change. So let's look at each one of these scenarios one at a time and talk about some of the best practices. Of course, starting with networking, because what's the first thing that developers like to blame when things are not working, right? Network. So when you deploy workloads on Outpost, you need to ensure that Outpost has reliable and redundant connectivity back to the region. And why is that? Because think of Outpost as like one of the racks from our availability zones is basically dragged all the way to your data center. And for this model to work, it needs reliable connectivity to the mothership, right? So it's very important that you ensure that Outpost has connectivity to your on-premises environment, say represented in pink here, and to the AWS region represented in blue. These are essentially different VLANs that you can create when you're setting up your Outpost. Next is, let's talk about some of the larger events, like an issue in your data center or an event inside our availability zone. Look, these are rare events, but again, when you're thinking about running a mission critical workload, you want to make sure that all your bases are covered. So for high availability use cases, we strongly recommend customers that you deploy multiple outposts in completely isolated data centers. And the reason for that is that we strongly recommend that you create completely isolated fault domains, without any interdependencies between them. The very important thing to note here is that when you're deploying two outposts in two physically isolated data centers, make sure that you're connecting those outposts to a different availability zone in the same region or across multiple regions. Again, as I said, the whole idea is that how do you create completely isolated fault domains without any interdependencies? John, can you take the next two, please?
No worries. So we also have to examine how we handle redundancy across computer storage. So obviously Amazon gives us a certain amount of resiliency off the base services, so our EC2s, our EBSs, that kind of thing. But we also have to think about things slightly differently because the shared responsibility model is slightly differently. We have to think about things like capacity planning and monitoring because it's not quite the same as it is in regular cloud where what you do is your capacity planning is essentially your wallet and you think about things from a FinOps point of view. Your capacity is fixed here, so we have to do things like monitor our capacity using things like CloudWatch alarms and stuff like that to make sure that you don't try to overfill your outpost and run out of space. You also need to be able to think about this from a point of view of at the application layer for N+1, N+2 types of redundancy. So like I said before, in the OT world, everything you do is doubled up, so that we can have failure after failure after failure and still maintain a static level of service. And then we talk about static stability. So one of the things that we do on our outpost is we pre-fill the outpost to max so that we have extra servers already provisioned should we need them so we can move service back and forth in that environment. And that means that if we do have a failure and we do have to re-provision, we don't have to re-provision the entire EC2 if we don't want to. Although, because we have all of our automation as code, we have operations here as well. And so it's very important to us if we're going to go through this effort of bringing these cloud services into the OT world, that we start to tackle problems like CI/CD type problems, that we make sure that we can deploy. But how do we deploy? Well, we need to deploy to one outpost at a time because we can do zero downtime deployments. We do them regularly now, which is not usual for an EDB like us. But we do that with deploying to one instance at a time. We need to make sure that the releases that we do are as small as possible. That's not unusual for CI/CD. And we need to automate the deployment and rollback processes as much as is humanly possible to be able to achieve the fastest restore times that we possibly can. And we've been able to achieve that with our system. And this is what helps us and allows us to pivot because we have ultimately the most options now that we have this shared infrastructure layer across all our environments. Although it's completely separate. It's just a shared tool set. These are not the corporate environments. Of course, everything else is separated. And so I'll hand it over.
Thanks, John. Look, so we've covered quite a lot of stuff in the session, right? And I personally struggle to remember more than 3 things at a time. So what are those 3 key things that you can take away from this session, right? So number 1, keep it consistent. Keep your architecture consistent across cloud and at the edge, right? This is the whole idea is that you take out the complexity from your deployment. And as I discussed earlier, AWS capabilities allow you to do that. The second one is ensure you have redundancy at all layers, network, storage, compute, applications, database, at every layer. Especially important when you're running a mission critical workload. And finally, design for all failure scenarios, because whether you like it or not, failures are given in any large distributed complex applications. So, when you're running a highly available, resilient applications, planning and preparation is really your best protection. None of what we have discussed in this session is even remotely possible without cloud skill set, So I'll strongly urge you to invest in developing that skill set within your team. Check out skillbuilder.aws. We have over 500, hands-on labs and trainings and courses available to you. And that's all we have for you today in this session. Thank you so much for hanging out with us. And thank you to you, John, for taking time to share with us this details of this exciting project that Vector team has worked with us on.